Hello, welcome to this 5-minute tutorial on how to configure RPKI origin validation on an EOS or ARISTA-based network device. We will start by looking at our lab setup here. I built this inside AWS. So I have two ARISTA VOS devices and I have a RouterNator validator instance running on standard Ubuntu. The ARISTA images are what's available in the marketplace, so they're free trials you can do for the Cloud EOS router. It will work exactly the same on a physical ARISTA device, so everything you see here will work both as a virtual image, but also on any device you might have. So these two devices, so we will have VOS device number 2 and VOS device number 1. One will do the origin validation. I will use the other router to kind of send routes to it so we can look what it will, how the router will behave when it's sent an invalid route. There hasn't been much preparation on these two devices beforehand, so the only thing I did was to configure BGP. So we have a BGP session up and running in between these devices. Please note that this is inside the VPC, so nothing of this is happening on the internet, so it's in an isolated environment. So yes, BGP is up since 51 minutes. There's no prefixes received or accepted. There is nothing coming in between these two devices. This VOS2 device is the one that will do the actual origin validation. So according to the ARISTA documentation, you need to turn on this command: service routing protocols model multi-agent and reboot. So that is specific for using RPKI origin validation and perhaps other BGP features too. That is kind of using another type of BGP setup on the ARISTA device. So what we'll start is to set up a RTR session towards this RouterNator instance. That's been running for a good 3 hours here, so it has all the information we need. So we'll start configuring here. So we will go into the BGP router, and here we will configure. First, we need to configure a cache of some sort. So let's call it like that. And it needs to have a host name, so we will use the host name here. So it is available there. Private IPv4 address. Use the port 3323. We also need to turn on validation. So that's actually on into the system using eBGP and local. So you will see here that we have two commands basically turning on origin validation. So first we point towards cache server, we turn on the actual validation, and hopefully that should mean we do have RPKI up and running. Yes. So there's an RPKI connection here towards the RouterNator instance. It has been active for 33 seconds, and I assume we can do a detailed check here. See some throughput windows, maybe not that interesting. Can check out here, do a ROAS summary. So this is, so far we have downloaded 219,000 V4 and 41,000 V6 ROAS. We could look at the actual ROAS and see that we do get them in. So this is perfect. So this is already up and running. So this router is now, doesn't do origin validation, but it does have the information it needs. So let's take this first prefix, for example, and see how this would work. So let's log into this router and try to send this prefix over. As I said, this is an isolated environment, so nothing here is touching the internet. So what we can do here is to fake a route. So we point this to a null route. We try to announce it. There we go. Run show. To this peer. So here we're sending this /24 over to the other router using the wrong ASN. We can confirm it in this first router and see that we do receive one prefix, then we do accept one prefix. This is of course because we have not made a route map yet that does the origin validation on inbound, seeing as this prefix will now exist inside a routing table going towards the other router. So we need to create a route map, so we can call it the BGP RPKI in deny 10, so using the old style route map language. And in here we can actually turn on the kind of the matching process, where it will try to do a match, and if it's invalid it will drop it using the deny rule up here. So this means that it will deny if it does match the validity as invalid. And then we can apply this towards the BGP peer. So we go in here, you can check out the configuration looks like. So there's, as you can see, this neighbor does not have a route map. So we put it on the inbound. We should see here that this does indeed not accept the prefix. So now this prefix is not accepted anymore. So we receive 1, accept 0. Looking at the neighbor again, receive routes filtered. So this route is filtered, and we can see here that we do have validation codes where it's V for invalid, I for invalid, U for unknown. And there it comes using the wrong ASIN. So this is in a nutshell how you would configure OV on an ARISTA-based device. Quite simple, quite straightforward, I would say. Obviously, you need to spend a lot more work on the actual route maps to make sure they do everything else you need to do. For example, you need to filter small prefixes or whatever you need to do. But in a nutshell, this is how you get it going. And yeah, that's about it for ARISTA.